Hi there, welcome back to another video covering OCR Further Maths. Today we're doing a past paper question from the November 2021 series. This is question 3 from the Pure Core 1 paper. And this question is basically about roots of polynomials. I thought this was a really interesting question because it covers lots of different question types, so part A, B and C. So it covers lots of different question types and it links in a bit of a complex numbers knowledge as well. So let's get started. A function f of z is defined on all complex numbers z by f of z is equal to z cubed minus 3z squared plus kz minus 5, where k is a real constant. The roots of the equation are alpha, beta, and gamma, and these are the three things along with delta, so that's the fourth thing. These are Greek letters that we use to signify the roots of polynomials. And you're given that alpha squared plus beta squared plus gamma squared is equal to negative 5. So the first part is a 3 marker, and it says explain why f of z equals 0 has only one real root. So this is actually a writing explanation question, which is important to be able to do, and it's a bit about complex numbers as well. And it's important to be able to explain because that comes quite often in the OCR papers, being able to explain your reasoning behind the maths, probably more than in the A level. In the regular level, it comes up more in further maths than the regular level. So it's a cool question. And basically, the first thing you should look at is the fact that we have a cubic. So there are 3 roots in total. So cubic therefore means 3 roots. And they would be a combination of imaginary and real roots, or complex and real roots. Then we're given this little piece of information here. And that's the only other piece of information that we're given. So because of this k, we don't actually know what this cubic looks like and how many real or imaginary roots are. But we are given this bit of information here, that alpha squared plus beta squared plus gamma squared is equal to negative 5. Now, I would like you to kind of think, if I had 3 random roots, say, and they're all real, so we had alpha equals 2, beta equals minus 1, and gamma equals negative 3, for example. If you were to square alpha, it would give you 4. If you were to square beta, it would give you 1. So alpha squared equals 4, beta squared equals 1, and gamma squared is equal to 9. So when you add 4 plus 1 plus 9, this would give you a positive number. So if all 3 roots are real, then you would have a positive number for alpha squared plus beta squared plus gamma squared. But we have given a negative number here. So as negative 5 is negative, at least one root is complex. And we can kind of think about this as if you had, let's go with 3i squared, then this would go to minus 9, because you know that I squared is equal to negative 1. So that's the kind of thought process we're having here. And then what you'd say, so this is the first mark probably, minus 5 is negative, so at least one real root is, one root is complex. Then you would say that we know that complex roots come in conjugate pairs. So we know that if one of the roots is x plus iy, then we know that x minus iy is also a root. That's what conjugate pairs means. And therefore, you can say that 2 roots must be complex. And therefore, so this sign means therefore, this triangle of dots, therefore, 1 root or you could say only 1, that's probably better, because that's what it says in the question up here, only 1. Therefore, only 1 root is real, as there are 3 roots in total. So that should give you all 3 marks for that question. So you can see why I'm writing out. So in your real thing, you should be able to write out your answer. So these are the key things to write out. If I'll rub this part out, because this is just an explanation, and this is all an explanation as well. But this is the stuff you should be, everything left here is what you should be writing down. This is just an explanation. So we say that a cubic has 3 roots. We know that minus 5 is negative, so therefore at least 1 root is complex. Complex root come in conjugate pairs. 2 roots must be complex, and therefore only 1 root is real, as there are 3 roots in total. And that would give you all 3 marks for this question. Now for part B, it's a pretty simple question, pretty standard roots of polynomials question. Find the value of k. So the first thing I'm going to do is I'm going to define some terms that I'm going to be saying throughout this question. So if I write the sum of alphas, this is equal to alpha plus beta plus gamma, and etc. If there was more, if it was plus delta plus and so on and so forth. But for this one, you just have alpha, beta, gamma. Then if I say sum of alpha betas, that means alpha beta plus alpha gamma plus beta gamma, so on and so forth. And if I do sum of alpha beta gamma, that literally just means alpha beta gamma. So those are the kind of terms I'm going to be using. It's just shorthand so that it's a bit quicker for me to write down. So that's that first part done. And you can use this terminology in this shorthand notation in your exam, as the examiners will know what it means. So the first thing to look at is rewrite this polynomial. So we have z cubed minus 3z squared plus kz minus 5. So the first thing to know is that we know that the sum of alphas is equal to minus b plus a. And we know that the sum of alpha betas is equal to c over a. And we know that the sum of alpha beta gamma is equal to d minus b over a, sorry. So you should remember that just from learning roots of polynomials. That's the first thing we learn. So then we have that the sum of alphas is equal to minus this coefficient here, which is minus 3 over 1, which is just equal to 3. So that's what the sum of alphas is equal to. We know that the sum of alpha beta is equal to k over 1. So the sum of alpha beta is equal to k. And the sum of alpha beta gamma is equal to minus 5 over 1 is equal to 5. Now, we are given that alpha squared plus beta squared plus gamma squared is equal to negative 5. So is there a way that we can use any of these three terms to get alpha squared plus beta squared plus gamma squared? And this is quite a common question type, so you might already know. But what we can do is if we get alpha plus beta plus gamma squared, then if we expand that, then we'll get all three terms plus some other terms. So I'm going to go ahead and expand it. So it would be alpha squared plus beta squared plus gamma squared, and there'll be some other terms as well, which we can figure out. The other two terms will be plus 2 alpha beta plus 2 beta gamma plus 2 alpha gamma. You can expand this yourself a bit more slower if you want. But this is what the final answer will be. And what we can recognize is that this here is just the sum of alphas squared. This is what we're trying to figure out, alpha squared plus beta squared plus gamma squared. Sorry, what we're given, this part here we're given, and then this part here is just 2 of the sum of alpha betas. And what we actually know, this is what we're trying to figure out. This is what's equal to k, right? So we can substitute k into here. We know this value and we know this value. So the sum of alphas is 3 squared. This is minus 5 here. And then we have plus 2k. So that would give us that 9 plus 5 equals to 2k, and that k is equal to 7. So that's our final answer for part B. Now, the final part of this is probably the easiest part, and this is a simple substitution for roots of polynomials. So you can see we're kind of covering all the different types of questions here. First we did trying to find out a value of a polynomial, and now we're trying to do a substitution to find a new polynomial. So it says find a cubic equation with integer coefficients that has these roots. So this is a simple substitution question. So we would have u is equal to 1 over alpha as our substitution. So then we know that alpha is equal to 1 over u. And because we know alpha is a root of f of z, you can plug this root into this equation. So you would get that 0 equals 1 over u cubed minus 3 1 over u squared plus k 1 over u minus 5. Then we know this would give us 1 over u cubed equals 0 minus 3 over u squared plus 7 over u, because we know that k is 7 from the previous part, and then minus 5. Now if we times both sides by u cubed, we know u cubed times 0 is again 0, then u cubed times 1 over u cubed is 1. Then this would give us 3u plus 7u squared minus 5u cubed. And that's our final answer for part C. So overall, this is quite a long question. It's worth 8 marks in total, but they split it out pretty nicely so that it covers a wide range of topics. So if you're able to do all these questions pretty simply, then you probably know you have a strong grasp of roots of polynomials, which is why I decided to cover it today. So I hope this video was useful and you enjoyed, and I'll see you in the next one.